BF3. Okay, now, here's something to be thinking about, so you don't have to reinvent the wheel every time. I have this compound. If I did this compound, I would come up with the same answer. See what I have done? Now we know boron is our central atom, so that these halogens are going to be out and around. If I just substitute a family member for a family member, that if I've just done this one, I shouldn't have to rethink how to do that. It's going to be the same. Or Bi3. Likewise, if I take a step backwards, we just did that. Okay, and we know about it. If we look over there, I could ask you all those questions. We're really in Chloride. Let's go back to it. How many triples in it? None. How many doubles? None. How many singles? Two. How many lone pairs on the central atom? None. Okay. If I ask you to do that, you shouldn't even have to lift your pencil. You can tell me immediately, no triples, no doubles, two singles, no lone pairs on the central atom. All you're doing is substituting for a family member. And if I went to this time, I'm substituting the family member here, but it's for the central atom. Everything's going to be the same. So don't start from scratch every time. Start seeing these trends. So we could do this, or this, or this, and we would end up with the same answers. In fact, hydrogen. Remember, hydrogen is really nasty because sometimes it fits in the 1A family, sometimes it fits in the 7A family, and your textbook in its periodic table shows it both places. And for electronegativity, it's something different still. We stuck it in there between what and what for electronegativity. Anybody remember what we did with hydrogen for electronegativity? Between what and what? Everybody remember? Well, let's backtrack. Electronegativity. How greedy are you for electrons? Tendency to attract electrons. As you go across the family, what happens? Increase or decrease? Increase. Increase. As you go down family? Decrease. But for hydrogen, I said it's weird, and you're going to have to remember it was between what and what. Anybody know?
Is it helium and
Carbon and something.
Okay, carbon and something. Not nitrogen, it goes between B and C. BC. So, hydrogen fits, and you just have to memorize that. It's a little bit more electronegative than boron, a little bit less than carbon. But Russell knew it was somewhere close to carbon. Okay, let's get back up here to the problem at hand. But the point is, halogens can substitute for each other, and hydrogens can substitute with the halogens. Okay, so we're really doing this one. Okay, I would look at it, and the first thing I would think of is, high alert, because I see boron in there, and I think, I'm going to violate the octet rule for us. So we go through. Need, available, and then share. Okay, boron. Tanya, how many does it need? 6. Good job. And then we have 3 fluorines, and each fluorine needs how many, Emily? Each fluorine needs 8. Let's see, 24 and 6, we got 30. Okay, now let's think available here. Kashan, the boron comes in with how many? 3, yes it is. And we have 3 fluorines, and each fluorine comes in with how many, Timothy?
7.
7. Okay, so let's see, 21 and that. We have 24. So we're going to share how many, Marco?
Oh, 6. Yes.
6. Okay, and we know boron is the central atom because we have just one of it. Or, I think as Sarah said a little while ago, it's first. But don't go by it's first. Go by that you have just one of them. So we come over here, and I can pick. I can pick the 2 sides in the bottom, or I can pick the top and the 2 sides. Doesn't matter. because this is bookkeeping. We don't know right now what the actual shape is of this molecule. Now, each fluorine is in the same position. So, Antonio, how many more pairs does each fluorine need?
3.
3 pairs, exactly, because it had access to 2 electrons or 1 pair already, so we can treat those the same. Is this a finished product? Okay, yeah, because that guy doesn't need an octet. And at this point, we start checking. Did we share 6? 1, 2, 3 pairs or 6 electrons? Check. Then available, and this is something students overlook. You must check available, and you'll see why later this morning. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Check. And then the last way you check is, does everybody have an octet that needs it? If I cover up that boron, each fluorine has access to 8. So we know each fluorine is in good shape. Then the boron has the 6 that we know by rule 3 is what it wants. Okay? Are we all right on that?